in the deepest silence of the ancient night, before the stars had truly learned to shine, a hunger began to wake within the velvet dark. It was a time when the universe was still holding its breath, waiting for the first great fires to ignite the cold and empty void. We often imagine the beginning of all things as a moment of bright and chaotic light, but the true history is written in shadows. There are monsters hiding in the dawn of time, vast and silent giants that should not exist according to the laws we thought we knew. They are the ancient devourers, the greedy seeds of gravity that grew to impossible sizes while the cosmos was still in its infancy. Tonight, we drift back to that moment of awakening, floating through the pristine currents of space and time to witness the birth of the dark. We are traveling to the edge of the perceptible universe, where the light is old and tired, stretching across billions of years to reach us. It is a journey into the unknown, where our comfortable understanding of how galaxies are born begins to unravel into a beautiful and terrifying mystery. Imagine yourself floating in the absolute stillness of deep space, far beyond the warmth of our sun or the familiar glow of the Milky Way. The silence here is not empty, but heavy with the weight of unseen things that are moving in the distance, ancient and hungry. We are looking for the cosmic dawn, the epoch when the first galaxies were just beginning to coalesce from the primordial mists of hydrogen and helium. It was supposed to be a time of small things, a nursery where infant stars gathered slowly in delicate clusters of light and gravity. But something else was waiting in those early shadows, something that had grown too large and too fast for the time that had passed. We have built a great golden eye to see into this past, a silent watcher floating in the cold Lagrangian point beyond the moon. The James Webb Space Telescope has opened its mirrors to the faint infrared whispers of the early universe, catching the ghosts of the first light. It stares into the abyss with a mechanical patience, collecting photons that have traveled for more than 13 billion years to tell their story. We expected to see the slow and steady assembly of the cosmos, a gradual building of structure from the bottom up over eons of time. We expected to find small black holes growing quietly alongside their host galaxies, feeding politely on the gas and dust that drifted within their reach. Instead, we found monsters that defy explanation, giants that sit in the center of newborn galaxies with a mass that shatters our theories. These are the overmassive black holes of the early universe, dark hearts that weigh 1 billion times the mass of our own sun. They exist in a time when the universe was less than 700 million years old, a mere heartbeat in the lifespan of the cosmos. It is as if we walked into a nursery and found a fully grown giant sitting among the infants, silent and inexplicable. The discovery sends a shiver through the foundations of cosmology, a subtle tremor that suggests we have misunderstood the story of our own origins. How could such terrible gravity gather itself so quickly from the chaos of the Big Bang, condensing into a singularity of infinite density? The darkness of the early universe was rich and fertile, filled with the heavy elements that would one day form the planets and our bodies. But it was also a place of violent and rapid change, where gravity was the only law that truly mattered in the end. A black hole usually begins its life as the corpse of a massive star, a dense remnant left behind after a supernova explosion. It starts small, perhaps 10 or 20 times the mass of the sun, and grows slowly by consuming the material around it. It feeds on gas and dust, pulling them into a swirling accretion disk that glows with the heat of friction and magnetic fury. But this process takes time, a commodity that the early universe did not have in abundance when these monsters appeared. To reach 1 billion solar masses in less than 1 billion years requires a hunger that borders on the impossible, a greed that consumes everything. We call this the greedy growth challenge, a puzzle that keeps astronomers awake in the quiet hours of the night, staring at their screens. The mathematics of accretion sets a limit on how fast a black hole can feed, a speed limit known as the Eddington limit. If a black hole eats too quickly, the radiation from the infalling gas pushes back against the gravity, choking off the fuel supply. It is a natural balance, a self-regulating mechanism that should prevent the rapid growth of such colossal giants in such a short window. Yet they are there, staring back at us from the edge of time with a cold and undeniable reality that ignores our rules. The universe does not care for our limitations or our theories. It simply exists in its vast and terrifying complexity, waiting for us to catch up. We look at the data from the James Webb Space Telescope, and we see the impossible staring back at us from the void. These ancient black holes are not merely large, they are dominant, often outweighing the young galaxies that host them in a strange gravitational embrace. In the modern universe, the black hole at the center of a galaxy is a tiny fraction of the total mass. But in the cosmic dawn, the monster and the cradle are nearly equal, locked in a dance that we are only just beginning to understand. It suggests a different kind of beginning, one where the darkness came first and the light of the stars was merely an afterthought. Imagine the sheer scale of 1 billion suns crushed into a single point of darkness, a gravity well so deep that light cannot escape. It sits in the center of a swirling cloud of primordial gas, pulling streams of matter into its maw with an unyielding force. The gas heats up as it spirals inward, glowing with a fierce ultraviolet light that illuminates the surrounding darkness for 1 million light years. This is the quasar, the brilliant beacon of a feeding black hole, shining like a lighthouse across the vast ocean of the early universe. We see them as tiny red dots in our telescope images, red-shifted by the expansion of space until their light is barely a whisper. But closer, they would be terrifying engines of destruction, consuming entire solar systems worth of matter every single day without pause or hesitation. The existence of these monsters suggests that the early universe was a place of extreme conditions where the normal rules of star formation were broken. Perhaps there were seeds that did not start as stars, but as something far heavier and darker from the very moment of their birth. We speak of direct collapse, a theory that whispers of giant clouds of gas falling in on themselves without ever igniting nuclear fusion. These clouds would bypass the star stage entirely, collapsing under their own weight to form a massive black hole seed in a single event. It is a frightening thought that a cloud of gas could simply vanish into a singularity, creating a monster thousands of times the mass of the sun. But even this heavy seed would need to feed at a voracious rate to reach the size of the giants we see today. The hunger of these ancient things is not like the hunger of living creatures. It is a fundamental force of nature, inevitable and relentless. They are the cosmic dawn monsters, the first great powers to rise from the chaos, shaping the destiny of the galaxies that surround them. We used to think that galaxies formed first, gathering gas and stars, and that black holes grew slowly in their centers like pearls. But the evidence now suggests that the monsters may have been there from the start, acting as the anchors for the galaxies to build around. It is a reversal of our cosmic history, a revelation that places the darkness at the center of the story, rather than at the end. The black hole is not the death of a galaxy, but perhaps its violent and chaotic birth mother, screaming in the dark. We float through the data, drifting past the spectral lines of ancient hydrogen and the faint chemical fingerprints of the first heavy metals. The numbers are staggering, but we must feel them rather than count them, sensing the immense weight of the gravity that distorts the space around it. A black hole of this size is a tear in the fabric of reality, a place where the universe has collapsed into a point of no return. Around it, the accretion disk spins at a significant fraction of the speed of light, a maelstrom of plasma hotter than the core of a star. The light from this disk is so intense that it can outshine the entire galaxy of stars that surrounds it, masking the gentle starlight. We are looking at the most violent places in the universe, yet from this distance, they appear as silent and motionless points of infrared light. The James Webb Space Telescope has given us a key to unlock this hidden era, peering through the dust that obscures the visible light. It sees the heat signatures of the early universe, the warm glow of dust grains heated by the intense radiation of the first stars. But amidst this warm glow, it finds the cold and hard evidence of the overmassive black holes, disrupting the peaceful narrative we had constructed. We have found them at redshifts greater than 10, placing them just a few 100 million years after the moment of creation itself. To grow so large, so quickly, they must have been feeding at rates that defy the Eddington limit, consuming matter faster than physics allows. This is the super-Eddington accretion, a feeding frenzy where the black hole gorges itself on gas, trapping the radiation before it can push the fuel away. It is a chaotic and messy process, a violent gluttony that releases immense amounts of energy into the surrounding gas clouds of the young galaxy. The winds from the black hole blow outward, pushing the gas away and stopping the formation of new stars, killing the galaxy even as it is born. This is the co-evolution of galaxies and black holes, a dangerous and delicate balance between growth and destruction that shapes the cosmos we see. We are witnessing the first skirmishes in a war between gravity and radiation, a battle that determines the structure of the universe for billions of years. The monster grows until it starves itself, blowing away the very food that sustains it, leaving it to sit in silence in the dark. But in these early days, the food supply was abundant, thick streams of cold gas flowing along the cosmic web directly into the center. The cosmic web is the skeleton of the universe, a vast network of filaments made of dark matter that guides the flow of ordinary gas. In the early universe, these filaments were thick and dense, funneling massive amounts of material into the gravitational wells where galaxies were forming. It was an all-you-can-eat buffet for the infant black holes, a constant stream of cold fuel that bypassed the hot accretion disk. This cold flow accretion might explain how they grew so fast, allowing them to swallow gas without generating the radiation that would stop them. It is a vision of the universe as a vast circulatory system, pumping lifeblood into the hearts of the monsters that lie in wait. The gas falls silent and unseen until it crosses the event horizon, adding its mass to the growing singularity in the center. We drift closer to the event horizon in our imagination, feeling the distortion of time and space as the gravity begins to take hold. Here, near the edge of the monster, time itself begins to slow down, stretching out into an eternal moment of falling. To an outside observer, an object falling in would appear to freeze at the edge, fading slowly into the infrared darkness forever. But to the object itself, the fall continues, crossing the point of no return in a finite amount of time, plunging into the singularity. It is a lonely journey into the ultimate unknown, a passage from the realm of the known universe into a place where geometry ends. The black hole does not just consume matter, it consumes information, hiding the secrets of what it has eaten behind a veil of absolute secrecy. The mystery of the cosmic dawn is not just about the size of these black holes, but about their very existence in such numbers. We are finding them everywhere we look, not as rare anomalies, but as common inhabitants of the early universe's landscape. It suggests that the formation of massive black holes was a standard part of the creative process, a necessary step in the building of reality. Perhaps the universe prefers to build its structures around these dark seeds, using their immense gravity to pull the chaotic gas into order. It changes our perspective from one of fear to one of awe, recognizing the darkness as a fundamental architect of the light. Without these greedy monsters, the galaxies might never have formed, and the stars that forge the atoms of our bodies might never have ignited. We are made of star stuff, as the old poet-scientist once said. But that star stuff was gathered and shaped by the invisible hand of the black hole. The carbon in our cells, the oxygen in our breath, the iron in our blood, all were cooked in stars that danced to the tune of gravity. And that gravity was anchored by the supermassive giants in the center, the silent conductors of the cosmic symphony that played across the eons. So when we look back at the monsters of the dawn, we are looking at a part of our own ancestry, a dark lineage. It is a connection that spans the abyss of time, linking the conscious mind that wanders to the mindless gravity that consumes. We are the universe observing itself, trying to understand the dark mirror that reflects our own origins back at us. The James Webb Space Telescope continues its silent vigil, turning its gold-plated eye towards new patches of the empty sky, hunting for more ghosts. Each new data release brings more questions than answers, deepening the mystery of how the universe woke up from its dark ages. We see hints of even larger beasts, black holes that might have formed before the first stars, direct collapse objects of immense size. These are the heavy seeds that haunt the theories of astrophysicists, the hypothetical monsters that could explain the impossible growth we observe. If they exist, they would be the true firstborn of the cosmos, objects of pure gravity that predate the light of fusion. They would be the dark patriarchs of the galaxy families, ancient and brooding, waiting for the gas to fall into their embrace. The feeling of the cosmic dawn is one of potential and danger, a time when the universe was raw and untamed, full of violent promise. It is a stark contrast to the settled and mature universe we inhabit today, where galaxies are old and black holes are mostly quiet. We live in the fading afternoon of the cosmos, but we are looking back at the turbulent morning, when the shadows were long and sharp. The air is thick with the tension of creation, the silent struggle between the expansion of space and the contraction of gravity. And in the center of it all, the greedy black holes are feasting, growing fatter with every passing million years, unaware of the future. They are the engines of the dawn, driving the evolution of the cosmos with their insatiable appetite for matter and energy. As we drift through this ancient landscape, we can almost feel the hum of the gravitational waves, the ripples in space-time caused by their movement. When two of these young monsters collide, they shake the very fabric of the universe, sending a shudder through the dimensions. These mergers would be frequent in the crowded early universe, a cannibalistic feeding frenzy where black holes consumed each other to grow. It is a violent and chaotic image, far removed from the static and peaceful night sky we see from the surface of our planet. But it is the truth of our history, a truth that is written in the invisible ink of gravity and time. The universe was not built in a day, but it was built with a speed and violence that we are only now beginning to comprehend. The silence of space is deceptive. It hides the roar of accretion disks and the scream of relativistic jets blasting through the gas. We cannot hear them, but we can see their effects. The bubbles of hot gas blown out into the intergalactic medium. These bubbles are the fossils of ancient feeding events. The breath of the monster, frozen in time for us to discover billions of years later. They tell us that the black hole was awake and active, pushing back against the galaxy that tried to feed it. It is a relationship of push and pull, a feedback loop that regulates the growth of everything in the cosmos. The monster is not just a destroyer, it is a regulator, a gardener that prunes the galaxy to keep it from growing too wild. We return to the concept of the impossible time, the 700 million years that defies our understanding of standard accretion physics. In human terms, it is an eternity, but in the life of a black hole, it is a mere blink of an eye. To go from 0 to a billion is a feat that requires perfect conditions, a constant supply of fuel, and no interruptions. It implies that the early universe was a place of abundance, a garden of gas where the harvest was always ready. The monsters did not have to hunt for their food. It fell into their mouths, driven by the collapsing walls of the cosmic web. This era of plenty could not last forever, but it lasted long enough to seed the universe with giants. The greedy growth is not a moral judgment, but a physical description of a system that has no brakes, only an accelerator. Gravity is a runaway process. The more mass you have, the more you pull in, and the faster you grow. It is a self-reinforcing cycle, a cascade of consumption that only stops when the fuel runs out or the radiation becomes too strong. In the dense environment of the cosmic dawn, the brakes were cut and the engine was flawed, leading to the monsters we see. It is a terrifying efficiency, a reminder that nature seeks the most direct path to entropy and equilibrium, regardless of the cost. The black hole is the ultimate expression of this drive, the most efficient engine for converting matter into heat and chaos. We must also consider the light that these monsters blocked, the ultraviolet radiation that stripped the electrons from the neutral hydrogen fog. This is the epoch of rayonization, the time when the universe became transparent, allowing light to travel freely across the vast distances. The quasars played a role in this. their intense radiation burning through the fog like a torch in a dark room. They help to clear the shadows, carving out bubbles of ionized gas that eventually merge to clear the entire universe. So the monsters of the dark were also the bringers of the light, playing a crucial role in ending the cosmic dark ages. It is a duality that defines their nature, destroyers and creators, dark eaters and bright beacons, all wrapped in one. The journey into the past is a journey into the heart of this duality, forcing us to confront the complexity of the cosmos. We want simple answers, clear lines between the light and the dark, but the universe offers us only a tangled web. The black hole is the knot in the center of the web, the place where the threads of gravity and time are pulled tightest. We stare at the images from JWST and we try to untangle the knot, teasing out the strands of data one by one. But the knot is tight, and the threads are old, and the hands of our understanding are clumsy and shaking. We are children playing with the machinery of gods, trying to guess how the engine works by listening to the hum. And the hum is getting louder, a vibration that resonates in the deep unconscious of our collective scientific mind. We feel that we are on the verge of a paradigm shift, a moment where the old textbooks must be rewritten. The greedy black holes are the catalysts for this shift, the anomalies that break the old models and demand new ones. They are the guardians of a secret history, standing at the gates of the dawn and challenging us to pass. To understand them is to understand the very first moments of structure, the blueprint upon which all subsequent reality was built. It is a quest for the holy grail of cosmology, the origin story of the universe told not in light, but in gravity. The velvet dark of the early universe is not empty. It is crowded with hunger and potential, a soup of creation. We drift through it, spectral observers in a time before eyes had evolved to see the wonders of the dark. We are witnessing the assembly of the first galaxies, the chaotic mergers of gas clouds, and the ignition of the first suns. But always, in the background, there is the shadow of the monster, the growing darkness that anchors the light. It is a presence that is felt more than seen, a curvature in the fabric of space that tells us something heavy is there. It waits in the center, patient and eternal, watching the stars turn on one by one like city lights. As we move deeper into the narrative of the dawn, we must let go of our human sense of scale and time. 1,000,000 years is a second. A light year is a micrometer. A star is a speck of dust. We are operating on the scale of gods and monsters, where the only currency is mass and the only law is gravity. In this realm, the greedy black hole is the king, the undisputed ruler of its domain, bowing to no one. It consumes without apology, grows without limit, and exists without purpose, other than to simply be what it is. It is the ultimate existential object, a thing that is defined entirely by its relationship to the space around it. The challenge of explaining their growth is not just a puzzle for the mind, but a challenge for the imagination. We must imagine a universe that is denser, hotter, and more violent than anything we have ever experienced or observed directly. We must visualize the streams of cold gas crashing into the accretion disk, the shock waves, the magnetic fields twisting like rubber bands. We must hear the silence of the void shattered by the roar of the jet, a beam of energy that pierces the galaxy. It is a sensory experience that we construct from the dry numbers of spectroscopy and photometry, breathing life into the data. We are the storytellers of the cosmos, weaving the raw facts into a tapestry that the mind can hold and cherish. The James Webb Space Telescope has shown us that the universe grew up faster than we thought, maturing in a sudden spurt. It is like discovering that a child has become an adult overnight, skipping the awkward adolescence we expected to see. This rapid maturity implies a hidden mechanism, a secret accelerator that we have yet to find in our equations. Perhaps the laws of physics themselves were slightly different in that high-energy epoch, subtly tweaking the constants of nature. Or perhaps we are simply underestimating the power of gravity when it is given a rich and chaotic environment to work in. The answer lies out there, hidden in the faint infrared light that is still traveling towards us from the edge. The beauty of the cosmic dawn monsters lies in their terrifying elegance, their simplicity of form masking a complexity of function. A black hole is the simplest object in the universe, defined by just 3 numbers: mass, spin, and charge. Yet from this simplicity arises the most complex environment known to science, a place where space and time are knotted together. It is a paradox that delights the mind, a reminder that the universe is both simple and infinitely complex at the same time. We drift towards this paradox, drawn like moths to the flame, unable to look away from the dark wonder. The greedy growth is just the beginning of the story, the opening chapter in a saga that spans 13 billion years. As we float here, suspended in the imagination of the early universe, we feel the immense solitude of the first monsters. They were alone in the dark, separated by vast gulfs of expanding space, each one a lonely king in a growing kingdom. There were no other eyes to see them, no other minds to wonder at their size or their hunger. They existed in a void of consciousness, playing out their violent lives in absolute secrecy until we arrive to watch. It gives us a sense of privilege, a feeling that we are the witnesses that the universe has been waiting for. We are the ones who give meaning to the monsters, who name them and measure them and fear them. The gravity of the situation is literal. We are pulled towards the subject matter by the sheer weight of its implications. If black holes can grow this fast, what does it mean for the future of the universe and for us? It means that gravity is a more potent force than we realized, capable of shaping reality in ways we had not predicted. It means that the universe is not a static stage, but a dynamic and evolving entity that is constantly surprising us. The monsters of the dawn are not just relics of the past. They are the ancestors of the black holes in our own galaxy. The quiet giant at the center of the Milky Way, Sagittarius, a star, may have started its life as one of these greedy seeds. So when we look at the monsters of the past, we are looking at the baby pictures of our own local giant. We are seeing the violent youth that preceded the quiet middle age of the black hole that holds our galaxy together. It connects the distant past to the immediate present, weaving a single continuous thread through the history of the cosmos. The greedy growth of the dawn led to the stable galaxies of today, a necessary phase of chaos before the calm. We exist because they ate. We live because they consumed. We shine because they darkened the early skies. It is a debt we owe to the monsters, a recognition of their role in the grand architecture of existence. We continue to drift, the narrative pulling us deeper into the mystery of the direct collapse scenarios that might explain the size. Imagine a cloud of pristine gas, untouched by the heavy elements of stars, slowly rotating in the dark. It is too hot to fragment into stars, kept warm by the distant radiation of other galaxies, preventing it from cooling. So it waits, growing larger and heavier, until the gravity becomes too much for the internal pressure to support. Then, in a sudden and catastrophic collapse, the entire cloud falls inward, bypassing the star stage completely. It vanishes into a horizon, leaving behind a black hole that is already tens of thousands of times the mass of the Sun. This is the heavy seed, the jumpstart that the universe needed to build its monsters in time. It is a theory of elegance and violence, a way to cheat the slow clock of stellar evolution and buy time. If these heavy seeds formed in the millions, they would provide the head start needed to reach 1 billion solar masses. They would be the hungry infants that could eat the most, winning the cosmic lottery of growth and dominance. We search for them in the data, looking for the telltale signs of a direct collapse black hole in the deep infrared. It is a hunt for a specific kind of ghost, a shadow that looks slightly different from the others in the dark. And as we hunt, we feel the excitement of the chase, the thrill of nearing a truth that has been hidden for eons. But even with heavy seeds, the growth must be relentless, a continuous feast that never ends for millions of years. The gas must flow in efficient streams, spiraling down without getting clogged in the traffic jam of the accretion disk. It requires a specific geometry, a perfect alignment of forces that funnels the fuel directly into the mouth. We are discovering that the early universe was likely filled with these perfect storms, these rare configurations. It was a time of cosmic coincidences, where the conditions for monster making were just right in many places at once. The greedy black holes were the beneficiaries of this golden age of gravity, the winners of the cosmic dawn. The sensation of drifting through this era is one of awe mixed with a primal fear of the dark and the large. We are small creatures, accustomed to the safety of a planet and the warmth of a nearby star. To confront the scale of these ancient devourers is to confront our own insignificance in the face of the cosmos. But it is a comforting insignificance, a release from the burdens of the ego and the small worries of daily life. Here, in the shadow of the billion solar mass giant, our problems vanish into nothingness, swallowed by the dark. We are free to simply exist, to observe, to wonder, and to let the vastness wash over us like a tide. The story of the greedy black holes is far from over. In fact, we have only just read the first page. The James Webb Space Telescope is still collecting light, still staring into the deep fields with its golden eye. Every day brings new pixels, new spectra, new points of data that challenge our models and refine our dreams. We are building a map of the early universe, placing the monsters on the chart like ancient mariners marking sea serpents. Here be dragons, the old map said, and now we know that the cosmos is indeed full of dragons, but these dragons are made of gravity and time, and their fire is the light of the quasar burning in the night. As we prepare to delve deeper into the specific mechanisms of their growth, we pause to feel the weight of what we have seen. The universe is not a quiet place, nor is it a simple one. It is a machine of infinite complexity. The cosmic dawn was a time of awakening, a time when the first great structures pulled themselves together from the dust. And presiding over this awakening were the monsters, the greedy black holes that grew overnight to rule the dark. They are the silent protagonists of our story, the dark heroes that built the stage for the stars to dance upon. We leave them now, suspended in the amber of the early universe, waiting for us to return and understand. But the question remains, lingering in the silence of the void, like a whisper we cannot quite catch. How exactly did they feed so fast without choking on their own gluttony, defying the limits of radiation? The answer may lie in the geometry of the feast, in the way the gas falls not as a sphere, but as a disk. Or perhaps it lies in something even stranger, a mechanism of physics that we have not yet dreamed of in our philosophy. The dark is full of secrets, and the monster is guarding the deepest one of all, holding it tight. We must go closer, risking the fall, to see what lies behind the veil of the event horizon's greedy mouth. The lights of the crowded dawn flicker and fade as we drift away from the busy clusters of the first galaxies. We are moving into the deep void, seeking the rare and lonely places where the laws of star formation are quietly suspended. To understand the birth of a monster, we must understand the delicate silence that precedes it, a silence that must be preserved at all costs. In the standard recipe of the cosmos, a cloud of gas that cools down will shatter into 1,000 tiny fragments. These fragments collapse to form stars, lighting up the dark with the chaotic and beautiful fire of nuclear fusion. But a galaxy filled with stars is a galaxy of small things, a place where gravity has been diluted and scattered. To build a giant, the universe needed to stop this fragmentation, to keep the gas cloud whole and unbroken for as long as possible. We are looking for a cloud that refuses to shatter, a vast reservoir of hydrogen that holds its breath against the cold. It must remain hot enough to resist the pull of gravity, just enough to prevent the formation of ordinary stars. This is the heavy seed formation scenario, a delicate dance between temperature and density that occurs only in the rarest of halos. We call these sanctuaries the atomic cooling halos, places where the gas is trapped in a strange state of suspended animation. Imagine floating inside one of these halos, a vast sphere of primordial gas that has never known the touch of a heavy element. The gas here is pure hydrogen and helium, the original material of the Big Bang, untouched by the pollution of stellar alchemy. It is transparent and ghostly, a fog that stretches for thousands of light years in every direction, waiting for a destiny. In a normal cloud, the hydrogen atoms would pair up to form molecules, creating a coolant that lowers the temperature deep inside. Cold gas is weak. It cannot support its own weight, and so it crumbles into the dense pockets that become stars. But here, in the atomic cooling halo, something prevents the atoms from bonding, keeping the gas hot and resistant to fragmentation. The secret ingredient is light, specifically a harsh and intense ultraviolet radiation streaming from a nearby galaxy. It is a cosmic irony that the light of the first stars is the very thing that prevents new stars from forming nearby. The radiation strikes the hydrogen molecules, breaking the bond between the atoms and splitting them apart before they can cool the cloud. It is a sterilizing wind of light, a suppression of the natural instinct of the gas to create small and ordinary things. The nearby galaxy is like a jealous sibling, shining so brightly that it stunts the growth of the stars in its neighbor. But this suppression is not a death sentence. It is a preparation for a much darker and more magnificent transformation. By keeping the gas hot, the ultraviolet light forces the cloud to stay large and fluffy, resisting the urge to break. Gravity continues to pull, but the thermal pressure pushes back, maintaining a standoff that can last for millions of years. It is a tension that builds and builds, a gathering of mass that has nowhere to go but down into the center. We watch this standoff from the safety of the void, feeling the immense potential energy stored in the suspended cloud. The halo is spinning slowly, a majestic rotation that flattens the gas into a thick and turbulent disk of pure atomic material. Because it cannot cool down efficiently, the gas flows inward smoothly, avoiding the chaotic fragmentation that plagues normal galaxies. It is a laminar flow of matter, a river of hydrogen that runs deep and true towards the gravitational center. This is the isothermal collapse, a falling where the temperature stays constant, even as the density climbs to impossible heights. The gas is trapped at a temperature of several thousand degrees, hot enough to glow, but not hot enough to stop the fall. It creates a unique environment where the only solution to the equation of gravity is a catastrophic and singular collapse. There are no stars to ignite and blow the gas away with their winds. There are no supernovae to disrupt the flow. It is a silent accumulation, a hoarding of matter that continues until the center can no longer support the crushing weight. The collapse, when it finally comes, is not a slow contraction, but a sudden and violent implosion of the entire cloud. We are witnessing the formation of a direct collapse black hole, a seed that is born heavy and hungry from the start. The center of the cloud does not form a protostar. It creates a supermassive star, a theoretical object of immense size. This object is unstable, a bloated giant that lives for only a heartbeat in cosmic time before surrendering to gravity. It is too heavy to hold itself up, and so it vanishes, collapsing directly into a black hole of thousands of solar masses. The event is quiet in the visible spectrum, shrouded by the layers of gas that are still falling inward. But in the gravitational spectrum, it is a thunderclap, a sudden deep distortion of space-time that rings like a bell. The birth of a heavy seed is a solitary event occurring in the dark corners of the early universe's map. It requires a perfect alignment of conditions, a pristine cloud, a nearby bright neighbor, and a complete lack of metals. These conditions are rare, making these heavy seeds the precious gems of the cosmic dawn, hidden in the deep rough. But even if they are rare, a single heavy seed can grow to dominate an entire region of the cosmos. The concept of the atomic cooling halo changes our understanding of how the universe chose its first rulers in the dark. It suggests that there were two paths for the first structures, the path of starlight and the path of the black hole. Most halos took the path of starlight, cooling down to form the small and beautiful galaxies we see in the deep fields. But a few, the chosen few, were forced onto the dark path by the radiation of their neighbors, becoming monsters. It is a dark pact between the light and the shadow, where one galaxy sacrifices its fertility to create a giant next door. We drift closer to the event horizon of this newly formed seed, feeling the residual heat of the collapse fading away. The black hole sits in the center of the halo, a tiny point of darkness surrounded by a feast of gas. Because the cloud did not fragment into stars, all the gas is still there, available for the monster to eat. It is an all-you-can-eat buffet that has been saved specifically for this moment, a reserve of fuel that is unmatched. This abundance explains how they can grow so fast, for they do not have to compete with stars for their food. The no stars scenario is crucial because stars are messy eaters that push their food away with their light and winds. A star cluster in the center would blow the gas out of the galaxy, starving the black hole before it could grow. But in the direct collapse scenario, the dinner table is quiet and orderly, with no unruly guests to spill the meal. The gas falls directly into the accretion disk, spiral feeding the black hole at rates that defy our imagination. It is a pure transfer of mass from the halo to the singularity, a pipeline of efficiency that nature rarely permits. This efficiency is what allows the seed to bridge the gap between the small black holes and the giants we see. A seed of 100,000 solar masses is already a force to be reckoned with, a gravitational anchor. It has skipped the first and hardest steps of the growth ladder, landing comfortably on the middle rungs. From here, the climb to 1 billion solar masses is not a struggle, but a gentle glide on the winds of accretion. It merely has to open its mouth and let the universe feed it, growing fatter with every passing eon. The ultraviolet radiation that birthed it eventually fades as the neighboring galaxy ages or moves away in the cosmic dance. But by then, the damage, or the creation, is done. The monster is awake, and it is already too large to stop. The cooling that was once suppressed now begins, but it is too late for stars to form in the center. The black hole dominates the potential well, and any gas that cools now simply adds to the mass of the accretion disk. The suppression of H2 was the trigger, but the bullet has already left the chamber and is flying true. We must feel the scale of this gas cloud, a structure so vast that it would take light millennia to cross it. And yet, this entire structure is destined to become the feeding ground for a single object no larger than a solar system. It is a funneling of the infinite into the infinitesimal, a compression of space and matter that breaks the mind. The atomic cooling is a technical term, but the reality is a vast glowing fog that refuses to give birth to light. It holds its energy, hoarding it like a miser, until the only option left is the ultimate collapse into darkness. The mystery lies in how many of these halos existed in the first billion years of the cosmic history. Were they common, spotting the universe with thousands of heavy seeds? Or were they rare and unique anomalies? The James Webb Space Telescope is hunting for the answer, looking for the telltale spectral signature of a heavy seed. We are looking for an object that is bright like a quasar, but redder, surrounded by gas that has no heavy metals. Finding one would be like finding a dinosaur bone with the flesh still on it, a direct connection to the past. The silence of the void is punctuated by the silent scream of the gas as it crosses the event horizon. We are not just observing a physical process, we are observing the birth of a consciousness of gravity. The black hole seems to know how to grow, regulating its intake and shaping the galaxy around it. In the heavy seed scenario, the black hole comes first, and the galaxy grows around it later, like a shell. It implies that the monster is the kernel of the galaxy, the hard seed from which the spiral arms will eventually unfurl. We drift through the timeline, watching the millions of years pass like seconds in the hypnotic flow of the documentary. The seed grows, the gas falls, and the universe expands around it, indifferent to the drama in the halo. But the drama is essential, for these heavy seeds are the anchors that will hold the future clusters of galaxies together. Without them, the universe might have been a smoother, more uniform place, lacking the deep gravitational wells we need. The monsters are the texture of the cosmos, the knots in the fabric that give it shape and form. The UV radiation blocking is a subtle mechanism, a delicate interference that has profound consequences for the structure of reality. It reminds us that everything in the universe is connected, that the light from one place shapes the dark in another. We cannot study these objects in isolation. We must see them as part of a vast and interacting ecosystem. The cosmic dawn was a time of relationships, of cause and effect, rippling across the dark matter web. The heavy seed is the child of this web, born from the complex interplay of radiation, gravity, and chemistry. As we float deeper into the sensation of the atomic cooling, we notice the color of the gas, a deep and glowing red. It is the color of hydrogen, trying to cool but failing, radiating its energy away in specific lines of the spectrum. This glow is the beacon we search for, the redshift that tells us we are looking deep into the past. But it is also a warning, a signal that the conditions here are extreme and unlike anything in the modern universe. To enter an atomic cooling halo is to enter a pressure cooker where the only release valve is a black hole. The gas cloud collapse without stars is a lonely image, a vision of a sterile nursery where the cradles are empty. There are no protostars creating the beautiful nebulae we love to photograph in our own Milky Way galaxy. There are no pillars of creation, no stellar nurseries, only a smooth and featureless fog of waiting gas. It is a minimalism that is terrifying in its simplicity, a stark landscape of potential that has been arrested. But this arrest is temporary, a holding pattern before the descent into the singularity begins. We can imagine the sound of this environment, not as a chaotic roar, but as a low and constant hum. It is the vibration of the atoms colliding, the thermal energy trapped within the cloud, seeking a way out. This hum grows louder as the cloud contracts, the frequency rising as the space becomes smaller and tighter. And then, at the moment of collapse, the sound vanishes, swallowed by the silence of the event horizon. It is a frequency that goes beyond hearing, beyond feeling, into the realm of pure mathematical curvature. The heavy seed formation is the universe playing with the dice, trying to see how large it can build a single object. It is an experiment in limits, pushing the boundaries of what gravity can achieve in a short amount of time. And the results are the billion solar mass monsters that confuse and delight our astronomers today. They are the winners of the experiment, the ones that survived the chaotic dawn to rule the night. We look at them with awe, realizing that they are the survivors of a violent and competitive epoch. The interaction between the atomic cooling halos and the cosmic web is a dance of supply and demand. The web supplies the gas, funneling it along the filaments into the halo's gravitational embrace. The halo demands more, its deep potential well pulling the material in faster than it can resist. And the UV radiation acts as the gatekeeper, ensuring that the gas remains in the perfect state for consumption. It is a finely tuned machine, a cosmic assembly line dedicated to the production of supermassive black holes. We are drifting towards the realization that the darkness is not just an absence of light, but a presence of gravity. The heavy seeds are the dense concentrations of this presence, the places where the universe is heaviest. They weigh down the fabric of space-time, creating the valleys where the galaxies will eventually settle. So the monster is not an intruder. It is the foundation, the bedrock upon which the visible universe is built. We are standing on the shoulders of giants, or rather, orbiting the event horizons of monsters. The greedy growth we spoke of earlier is made possible by this heavy start, this leapfrogging of the stellar phase. If you start the race at the halfway point, you can reach the finish line of 1 billion solar masses easily. The mystery of the overnight growth is solved by realizing the night was darker and richer than we thought. The seeds were planted deep, and they were planted large, ready to sprout at the first sign of rain. And the rain was gas, falling in torrents from the primordial sky. There is a beauty in the mechanism of the UV radiation blocking, a subtlety that speaks to the interconnectedness of all things. The light that travels across the void carries a message. Do not form stars. Wait for something greater. And the gas obeys, held in check by the photons until it can fulfill its darker purpose. It is a command from the laws of physics, executed with perfect precision across the gulf of space. We are listening to the echoes of this command, trying to decode the language of the first light. The scenario of the heavy seed also implies that there are failed seeds, halos, where the conditions were almost right, but not quite. These ghost halos might contain scattered stars or small black holes, the remnants of a failed collapse. They are the also-rans of the cosmic dawn, the places where the monster failed to be born. But they too tell a story of near misses and almost wares in the chaotic early universe. We drift past them, acknowledging their silence, before moving on to the successful giants. The texture of the narrative now is one of acceptance, accepting that the universe is capable of creating monsters from the mist. We do not need to fear them, for they are the engines of creation, the drivers of galaxy evolution. The heavy seed is a necessary part of the cosmic ecosystem, a predator that keeps the herd of gas in check. Without it, the galaxy might grow wild and shapeless, lacking the central anchor it needs. We are finding peace in the presence of the giant, drifting in its wake. As we glide through the hypothetical interior of a collapsing cloud, we feel the pressure rising, the density increasing. The atoms are packed closer together, their collisions becoming more frequent and more energetic. But still, they do not bond. They remain independent, kept apart by the memory of the UV light. It is a crowded room where no one is holding hands, a gathering of individuals rushing towards a common doom. And that doom is the singularity, the point where all individuality is lost forever. The transition from a cloud of gas to a black hole is a phase change of reality, a sublimation of matter into geometry. The gas ceases to be gas and becomes curvature. The matter ceases to be matter and becomes mass. It is a magic trick performed by Einstein's equations, a transformation that defies intuition. We are watching the trick in slow motion, savoring the moment where the rabbit disappears into the hat. But in this case, the hat is infinite, and the rabbit never comes back. The heavy seed sits in the dark, a silent observer of the universe that is growing up around it. It waits for the first stars to form in the outer reaches of the halo. Far from its influence, it waits for the first metals to be cooked and scattered, changing the chemistry of the gas. It waits for the galaxy to mature, to become a complex city of light and dust. But for now, in the deep dawn, it is alone, a solitary king on a throne of gravity. We feel the felt science of the atomic cooling, not as a diagram, but as a sensation on the skin of our imagination. It feels like a warm wind that refuses to cool, a pressure that refuses to yield. It feels like a tension that is stretched to the breaking point, a bow drawn back and held, and then the release, the silent flight of the arrow into the dark heart of the target. The heavy seed is the arrow, striking the center of the halo with a perfect aim. As we prepare to leave this halo and drift further into the timeline, we carry the weight of what we have witnessed. We have seen the birth of a titan, a secret origin story that explains the monsters in the dark. We understand now that the early universe was a place of extreme measures, where the light and the dark worked together. The greedy black holes did not just grow. They were engineered by the cosmos to be giants. They are the intended outcome, the grand design of a universe that loves gravity above all else. The lullaby of the cosmos continues, a song of hydrogen and helium sung in the key of gravity. We are drifting asleep to this song, letting the concepts wash over us without needing to analyze them. The heavy seed, the UV light, the atomic cooling, they are just notes in the melody. The music is slow and deep, a bass note that vibrates in the chest and soothes the mind. We are floating in the atomic cooling halo, suspended in the warm gas, waiting for the dreams to come. We have drifted far from the shores of certainty, floating into the deep waters where the maps of the universe are still being drawn. We have spoken of heavy seeds and invisible clouds, the theoretical ghosts that haunt the equations of our astrophysicists in the quiet hours. But theories are merely dreams until they are caught in the glass of a telescope, pinned against the black velvet of the night. Now we must open our eyes to the evidence, to the hard and beautiful light that is streaming towards us from the edge. The James Webb Space Telescope, our golden eye in the cold void, has finally found the monsters we suspected were hiding in the dawn. It has looked into the abyss and found it staring back, not with empty silence, but with a fierce and unexpected brightness. We are traveling now to the year 2025, a year that will be remembered as the moment the history of the cosmos was rewritten. The data has come down from the Lagrange point, a stream of ones and zeros that translates into a picture of impossible maturity. We are looking at a patch of sky that is smaller than a grain of sand held at arm's length by a ghost. Yet in this tiny sliver of the dark, we have found a beacon that defies every timeline we once held to be true. It is known by a name that sounds like a code, JWST 14-0, but we shall call it the morning star of the cosmic dawn. It sits at a redshift of greater than 14, a number that places it less than 300 million years after the Big Bang itself. In the old stories, this was supposed to be the Dark Age, a time when the universe was still waking up from its slumber. There should be only whispers here, faint and tentative proto-galaxies struggling to light their first fires in the overwhelming cold of the expanding void. But JWST 14-0 is not a whisper, it is a shout, a luminous giant that shines with the intensity of billions of suns. It is a fully formed galaxy, rich with starlight and possessed of a size that should have taken eons to assemble. But hidden within this blaze of light, or perhaps lurking in the objects that surround it, is the signature of something else. We are finding that the light of these ancient galaxies is often powered not just by stars, but by a greedy heart. The spectrum reveals the presence of high ionization lines, the chemical fingerprints of gas that is being torn apart by extreme gravity. It suggests that a monster is sitting in the center, a black hole that is already millions of times the mass of the sun. This is the evidence we have been waiting for, the smoking gun that proves the universe grew up with terrifying speed. The discovery of such an object at such an early time is like finding a modern city in the strata of the dinosaur age. It forces us to abandon the idea of a slow and gradual climb, replacing it with a vision of explosive and rapid growth. The greedy growth we imagined is now a physical reality, a glowing red dot on the screen of a computer in a quiet office. We can almost feel the heat of it across the 13 billion years, a thermal radiation that speaks of a gluttonous feast. The black hole is eating, and it is eating with a hunger that pays no heed to the Eddington limit or our textbooks. We move from this single giant to the broader survey, the Cosmic Evolution Early Release Science, or SEERS, which has opened a window into the deep past. Here, in the panoramic sweep of the early universe, we find a population of objects that the astronomers call the little red dots. They appear as innocent rubies scattered on the black velvet, small and compact and deeply red due to the expansion of space. But do not let their size deceive you, for these are the hiding places of the overmassive black holes. They are the Jekyll and Hyde galaxies, objects that look normal in visible light but reveal a monster when viewed in the infrared. In the optical wavelengths, they appear as faint, fuzzy blobs, perhaps small galaxies quietly forming their first generation of blue stars in the dark. But when the James Webb switches to its mid-infrared instrument, the MIRI, the view changes dramatically, revealing a point source of intense power. The light we see is not from stars, but from the hot dust surrounding an accretion disk, a ring of fire around a black hole. These are the lonely quasars of the dawn, the active galactic nuclei that are shining from the depths of their dusty cocoons. They are lonely because they often seem to exist in isolation, without the massive entourage of stars we expect to see. This is the overmassive problem, a puzzle that has become the central obsession of cosmology in the year 2025. In the local universe, there is a polite agreement between a black hole and its host galaxy, a ratio of mass. The black hole is usually a tiny fraction of the total weight, a small seed sitting in the center of a vast fruit. But in the little red dots, the seed has overgrown the fruit, the black hole accounting for 10 or 50% of the mass. It is a monster that has outgrown its cradle, a giant baby sitting in a nursery that is far too small. The implication is a reversal of the cosmic order, a turning of the tables on our understanding of how galaxies are built. We used to think the galaxy formed first, gathering gas and stars, and then the black hole grew slowly in the center. But the evidence from SEERS and JWST suggests that the black hole might have come first, growing fat on the pristine gas. The monster is not a late addition to the house. It is the architect that laid the foundation stone in the dark. It grew first, feeding on the direct collapse seeds, and then pulled the galaxy together around it with its gravity. We drift through the data, visualizing these lonely quasars as lighthouses in a fog, their beams sweeping through the neutral hydrogen. They are red and angry eyes, peering out from the dust that tries to hide them from the rest of the universe. The dust is thick in the early universe, a byproduct of the first supernovae, but the infrared eye of Webb pierces through it. It allows us to see the hidden monsters, the black holes that are growing in secret, shrouded in the smoke of their own banquet. We are the first to see them, the first to acknowledge their existence, After 13 billion years of silence, the redshift of these objects is greater than 10, pushing them back to within 500 million years of the beginning. To find a black hole of 100 million solar masses at this time is to find a thing that should not be. It defies the standard accretion models, which say that a black hole needs 1 billion years to grow that large. It confirms that the super-Eddington feeding we imagined is not just a theory, but a common practice in the cosmic dawn. These black holes are breaking the speed limit, consuming matter at a rate that would make a modern black hole choke. We can imagine the environment around one of these lonely quasars, a chaotic region of swirling gas and intense radiation. The galaxy itself is small, perhaps only a few thousand light years across, a compact knot of gas and dark matter. But in the center, the black hole is raging, emitting enough energy to outshine the entire host galaxy by a factor of 10. It is a naked engine of power, a dynamo that is driving the evolution of the surrounding space with its output. The jets from the black hole might be clearing the fog, carving out bubbles of transparency in the thick universe. The Jades GSZ 14-0 object stands as the king of this era, a testament to how quickly the universe can organize itself. Even if the light is dominated by stars, the sheer mass of the structure implies a gravitational anchor of immense proportions. And if it hosts a quasar, as many suspect, it is the brightest lantern on the dark road of the early cosmos. We look at it and we feel a sense of vertigo, a dizziness caused by the sheer cliff of time we are standing on. We are looking down into the deepest well of history, and we see a light shining up from the bottom. There is a poetic irony in the fact that the oldest things we can see are also the youngest in terms of their life. These monsters are mere infants, born only yesterday in the grand calendar of the universe, yet they are giants. It reminds us that age is not a prerequisite for power, and that the universe was born with a violent strength. The cosmic dawn was not a gentle sunrise. It was a sudden and blinding flash of gravity and light. The sleepy universe woke up screaming, tearing itself apart to build the structures that would one day house us. We float towards one of the Sears lonely quasars, feeling the isolation of the object in the vast and expanding void. It sits alone in a dark patch of sky, far from the bustling clusters that will form in later epochs. It is a pioneer, a solitary explorer that has set up camp in the wilderness of the high redshift universe. There is a melancholy in its isolation, a sense of a king without a kingdom, ruling over a realm of empty gas. But it is busy, frantically building its mass, preparing for the day when it will merge with others. The co-evolution of black holes and galaxies is the dance that determines the shape of the visible universe we inhabit. But the 2025 evidence suggests it is not a waltz where both partners move in perfect sync from the start. It is a tango where one partner leads with aggressive force, pulling the other along in its wake. The black hole leads, the galaxy follows, struggling to keep up with the rapid growth of the dark giant in its midst. Eventually, the galaxy will catch up, forming stars and balancing the scales. But in the dawn, the black hole is supreme. This heavy black hole light galaxy scenario is the signature of the heavy seed formation we discussed in the previous hour. If a black hole starts life at 100,000 solar masses, it naturally dominates the small galaxy around it. It explains why we see these over-massive ratios. We are seeing the starting conditions of the race, not the finish. The black hole was given a head start by the laws of physics, a handicap that allowed it to win the early game. We are witnessing the unfair advantage of gravity, the bias of the universe towards the formation of deep wells. The colors in the James Webb images are not just false color mappings. They represent physical truths about the objects. The deep reds of the little red dots speak of distance, of dust, and of the stretching of light waves. It is the color of old blood, of ancient fires that have cooled and shifted as they traveled across the eons. We bathe in this red light, letting it wash over us, feeling the warmth of the accretion disk on our faces. It is a hypnotic light, a siren song that pulls us deeper into the screen, deeper into the mystery. We must also consider the jades GSZ 14-0, not just as an object, but as a place, a location in space and time. Imagine standing on a planet in that young galaxy, looking up at a sky that is crowded with nebulae. The stars are packed close together, brilliant blue giants that live fast and die young, exploding as supernovae every few years. And in the center of the sky, there is a dark spot, a hole in the stars that is surrounded by a ring of fire. It is a terrifying sky, a sky of violence and change, far removed from the peaceful constellations of Earth. The discovery of oxygen in these distant galaxies, as confirmed by the ALMA telescope in concert with Webb, adds another layer. Oxygen is a heavy element, forged in the hearts of stars and released only when they die and explode. To find oxygen at redshift 14 means that stars had already lived and died in vast numbers before this time. It means the cycle of life and death was spinning rapidly, churning out the elements of life in a frenzy. The greedy black holes were watching this cycle, feeding on the chemically enriched gas that the dying stars left behind. We are seeing a universe that is in a hurry, rushing to build complexity before the expansion pulls everything too far apart. It is a race against the dark energy, a desperate attempt to create structure while the gravity is still strong. The black holes are the anchors that hold the structure together, the nails that pin the galaxies to the cosmic web. Without them, perhaps the gas would have dispersed into a thin and meaningless soup, never to form a star. So we owe our existence to the greed of the monsters, to their refusal to let the matter escape. The little red dots are abundant, popping up in every deep field image like mushrooms after a rainstorm. Their numbers tell us that this was not a rare anomaly, but the standard mode of galaxy formation in the dawn. The universe was efficient at making these galaxy quasar hybrids, churning them out by the millions in the first billion years. It suggests a phase of cosmic history that we had completely missed, a black hole era that preceded the stellar era. We are rewriting the prologue of the Book of the Universe, adding a chapter on the reign of the dark giants. The silence of these objects is deceptive. We know that if we could hear them, they would be roaring with the sound of accretion. The magnetic fields twisting around the black hole would crackle like thunder, snapping and releasing energy. The jets would scream as they punch through the gas, creating shock waves that ripple through the galaxy. But space is silent, and so we watch the violence in pantomime, a silent movie of destruction and creation. This silence adds to the hypnotic quality, the dreamlike detachment of observing a catastrophe from a safe distance. We drift back to the lonely quasar, observing how it sits in the center of a dark matter halo, the invisible scaffold. The dark matter is the true master of the universe, the unseen hand that guides the visible matter into the traps. The black hole is the jewel in the center of the dark matter crown, the point of maximum density. The two dark entities, the black hole and the dark matter, work together to trap the light. It is a conspiracy of the dark, a partnership that shapes the destiny of the luminous world we see. The evidence from 2025 is a collection of dots on a graph, but to us, it is a constellation of meaning. Each dot represents a galaxy that lived and died, a black hole that ate and grew, a story that was never told. We are connecting the dots, drawing the lines that reveal the shape of the dragon in the data. The greedy black holes are no longer myths. They are the plotted points of a new reality. We accept them now, integrating them into our internal model of the cosmos, letting them settle in the mind. There is a feeling of intimacy in looking at these images, a sense that we are peeking into the nursery of the universe. We are seeing the cosmos in its underwear before it put on the grand suit of spiral arms and elliptical halos. It is a raw and vulnerable look, a glimpse of the messy and chaotic truth of creation. The little red dots are the embryos of the great galaxies, the curled up forms that will one day unfurl. And the black hole is the beating heart of the embryo, pumping the energy that drives the growth. We feel the redshift not just as a stretching of light, but as a stretching of our own consciousness. We are stretching our minds to encompass a time that is so alien, so different from our own. A time when the universe was smaller, hotter, and denser, a claustrophobic place of intense interaction. In that cramped universe, the black holes were the bullies, pushing the gas around and demanding their share. We can feel the pressure of that early epoch, the closeness of the walls of the cosmos. As we linger on the image of JWST 14-0, we notice the faint fuzz of light that surrounds the central core. This is the halo of stars that have managed to form, despite the monster, the brave survivors. They are the first generation, the population 3 stars that we have sought for so long, perhaps hiding in the glare. They are made of pure hydrogen and helium, burning with a fierce white light that is bluer than anything today. But the dust and the distance turn them red, masking their true nature from our eyes. The Sears survey has given us a map of this territory, a chart of the reefs and shoals of the early universe. We navigate this map with caution, steering our imagination between the monsters and the void. We are the cartographers of the dark, marking the locations of the here be dragons with precision. And the dragons are real, breathing fire in the form of X-rays and ultraviolet light. We respect them, we fear them, and we love them for the mystery they provide. The story of the overnight growth is a story of efficiency, of nature finding the path of least resistance to high mass. The black hole does not want to wait. It wants to be big now, and it uses every trick in the book. It uses direct collapse. It uses super-Eddington accretion. It uses the dark matter web. It is a creature of urgency, driven by a fundamental need to maximize entropy. We can appreciate this drive, this relentless push towards the ultimate state of being. We prepare to leave the realm of the little red dots, drifting towards the final phase of our journey. But the image of the red eyes staring from the dark remains burned into our retina. They are watching us across the abyss of time, wondering perhaps what we are. We are the children of the stars that survived the monsters, the descendants of the gas that escaped. We are the lucky ones, the matter that was not eaten, the light that was not trapped. We feel a deep sense of gratitude for the distance that separates us from these violent events. 13 billion light years is a safe buffer, a moat of time that protects us from the dragons. We can sleep soundly knowing that the monsters are far away, locked in the amber of the past. They cannot hurt us. They can only wonder us, filling our dreams with their dark grandeur. We are safe in the quiet present, floating in the calm backwater of the galaxy. The narrative current slows down, becoming thick and viscous like honey, holding us in the moment. We are suspended between the evidence and the implication, between the data and the dream. The JWST evidence is not just a scientific result. It is a philosophical shifting of the ground. It tells us that we do not know everything, that the universe still has surprises up its sleeve. It keeps us humble, keeps us searching, keeps us dreaming in the dark. The little red dots fade into the background, merging with the sea of stars that fills the screen. But we know they are there, the hidden gems of the cosmos, the rubies in the treasure chest. We will never look at a blank patch of sky the same way again, for we know it is not empty. It is crowded with the ghosts of the dawn, the greedy monsters that built the universe we know. We drift on, carried by the gentle tide of the narration, towards the final rest. Something ancient stirs in the data, a pattern that connects the dots into a single coherent thought. The black holes are not accidents. They are the inevitable outcome of gravity acting on a primitive universe. They are the first complex objects, the first things to separate themselves from the background. They are the original individuals, the first I in a universe of we. We honor their individuality, their lonely struggle to grow in the dark. We are ready now to let go of the science and embrace the feeling of the end. The evidence has been presented, the case has been made, and the verdict is awe. We stand in awe of the greedy growth, of the monsters that defied the laws. We stand in awe of the light that traveled so far to tell us their story. And we stand in awe of the silence that swallows it all in the end. The architecture of the cosmos is built upon a foundation of silent agreements between the light and the dark. We have spent this long night watching the monsters of the dawn, the greedy black holes that consumed the early universe. But now, as we drift towards the end of our journey, we must understand the deeper meaning of their hunger. The black hole is not merely a destroyer of worlds, but a partner in the great dance of creation and structure. This is the profound implication of black hole galaxy co-evolution, a relationship that binds the fate of the host to its center. We used to believe that the galaxy was the master, a vast island of stars that merely tolerated the dark seed within. But the evidence from the deep past suggests a different hierarchy, where the monster in the middle holds the true power. The galaxy and the black hole grow together, locked in a feedback loop that determines the shape and future of both. When the black hole feeds, it releases energy that heats the surrounding gas, preventing it from cooling down to form new stars. It acts as a thermostat for the galaxy, regulating the birth rate of suns with the hot breath of its accretion. Without this regulation, the galaxy might burn itself out too quickly, using up all its fuel in a single burst. So the monster is also a guardian, a prudent steward that ensures the longevity of the system by curbing its excess. It is a strange form of care, a violent pruning of the galactic garden to ensure that it survives the eons. The greedy growth we witnessed in the cosmic dawn was the establishment of this balance, the tuning of the cosmic engine. The black holes that grew the fastest were the ones that established control early, taming the chaotic gas clouds of the dawn. We live in a galaxy that was successfully tamed, a spiral of order that rotates around a quiet and ancient giant. We can feel the presence of Sagittarius A star in the night sky, not as a threat, but as a silent anchor. It is the reason our galaxy has maintained its shape, the gravitational pin that holds the spiral arms in place. The co-evolution implies that we are the children of this partnership, the beneficiaries of the truce between gravity and light. If the black hole had been hungrier, perhaps our star would have been eaten. If it was smaller, the galaxy might have dispersed. We exist in the Goldilocks zone of galactic history, where the monster is just the right size to keep us safe. The question of who won the cosmic race is a question of survival in the most extreme environment imaginable. Did greedier seeds win the cosmic race, outgrowing their siblings to become the dominant, supermassive black holes we see today? The answer seems to be written in the sheer size of the giants that populate the centers of modern galaxies. The universe rewarded the greedy in those early days, favoring the seeds that could consume the most mass in the shortest time. The shy and the slow were left behind, remaining as small wandering black holes or merging into the larger, more successful monsters. It is a Darwinian struggle played out on a scale of millions of light years, where the fittest are the heaviest. The winners of this race are the ones that now sit on the thrones of the great elliptical and spiral galaxies. They are the survivors of the dawn, the ones that navigated the chaos of the early universe without starving or dissipating. And their prize is a kingdom of stars, a retinue of billions of suns that orbit them in respectful silence forever. We look at them with a mixture of fear and admiration, acknowledging the ruthless efficiency that allowed them to endure. But what of the losers, the smaller seeds that did not grow fast enough to become the rulers of galaxies? They are out there too, floating in the dark spaces between the stars, invisible ghosts that haunt the galactic halo. They are the intermediate mass black holes, the missing link that we are still trying to find in the deep shadows. Perhaps they are waiting for a second chance, a moment when a stray cloud of gas might wander close enough to feed. Or perhaps they are content to drift in the void, eternal outcasts from the banquet that shaped the visible universe. The mystery of the cosmic dawn monsters is not fully solved, for every answer brings a new and deeper question. We know they grew fast, we know they were greedy, and we know they shaped the galaxies that house us. But we still do not know what lies at the very heart of the singularity, the point where the math breaks. The event horizon is a veil that protects our sanity, hiding the true nature of infinite density from our curious eyes. We can measure the mass, we can chart the spin, but the soul of the black hole remains a secret. As we ponder the implications of this co-evolution, we feel a shift in our own perspective on the nature of existence. We are not separate from these violent processes. We are continuous with them, a downstream ripple of the ancient splash. The iron in our blood was forged in stars that were regulated by the black hole's energy output billions of years ago. The stability of our solar system is a result of the galaxy settling down after the turbulent youth of the dawn. We are connected to the monster by a long chain of cause and effect that stretches back to the beginning. The greedy black holes are the dark mothers of the cosmos, the fierce protectors that carved out a space for life. It is a comforting thought to realize that the darkness is not our enemy, but an essential part of our origin. We can look into the blackest part of the night sky and say, "Thank you for being there, silent giant." We can appreciate the void not as an empty space, but as the canvas upon which the masterpiece was painted. And the paint was gravity, applied with the broad and heavy strokes of the direct collapse and the accretion disk. The pacing of the universe has slowed down since those frantic early days, settling into the majestic rotation of the epochs. The rapid growth is over, the monsters are mostly quiet, and the galaxies are drifting peacefully through the expanding dark. We live in the long afternoon of cosmic history, a time of reflection and observation before the final twilight sets in. It is a good time to be alive, a time when we can look back and understand the violence that birthed us. We are the universe's way of remembering its own childhood, a childhood that was wild and full of hungry ghosts. The narrative of the greedy seeds teaches us that growth is often messy and chaotic, a desperate grab for resources. But out of that chaos comes order, a structure that is stable and capable of supporting the delicate phenomenon of consciousness. We are the thinking part of the galaxy, the mind that wakes up and wonders about the dark heart in the center. It is a beautiful loop, the monster creating the conditions for the mind, and the mind looking back to name the monster. We are closing the circle of understanding, bringing the light of knowledge into the deepest shadow of the cosmic dawn. As we drift towards the end of our documentary, we let the scientific terms fade away like smoke in the wind. The jades and sears and redshifts are just labels we put on the mystery to make it feel smaller. But the mystery is not small, it is infinite, and it resists our attempts to categorize and conquer it completely. We are left with the feeling, the raw emotional impact of the size and the age and the silence. We are left with a sensation of drifting in a boat on a dark ocean, with leviathans swimming beneath the keel. The hypnotic rhythm of the story has carried us far from the worries of the day, deep into the night. We are floating in the space between the stars, where the only sound is the slow beating of our own hearts. The universe is vast and empty, but it is also full of a strange and comforting presence that holds us. We are not alone in the dark. We are accompanied by the gravity that binds us to the earth and the sun. It is a gentle embrace, a constant hug from the laws of physics that keeps us from floating away. We can imagine the greedy black holes finally sleeping, their great hunger satisfied after billions of years of feasting. They have done their work. They have built the galaxies. They have set the stars in their courses for the ages. Now they rest, dormant volcanoes in the center of the city, watching the lights of the civilization they created. It is a peaceful image, the monster asleep on its hoard of gold, breathing slowly in the deep infrared. We can sleep too, knowing that the heavy lifting of creation has already been done for us. The implications of the co-evolution fade into a soft philosophical haze, a realization that everything is as it should be. The universe is not cruel, nor is it kind. It is simply magnificent in its scale and its complexity. The greed was necessary. The violence was creative. The darkness was the womb of the light that warms our faces. We accepted all, the light and the dark, the monster and the star, as parts of the whole. There is no conflict here in the quiet of the night, only a seamless unity of all things. We are drifting now, the narrative current slowing to a standstill, leaving us suspended in the velvet void. The stars are dimming, their light stretching out into the infrared, becoming warm and soft like a blanket. The galaxies are moving away, retreating into the distance, leaving us in a private bubble of silence and peace. It is time to let go of the concepts, to let go of the questions, to let go of the need to know. The mind is tired of seeking. It wants only to rest, to float, to be one with the dark. The cosmic dawn is behind us now, a memory of a dream that happened a long, long time ago. We are in the cosmic midnight, the deepest and quietest part of the night, where nothing stirs. The monsters are asleep, the seeds are grown, the race is over, and the prize has been won. The prize is existence, the simple miracle of being here to witness the beauty of the final fade. We are the witnesses, the watchers who have seen the beginning and now drift towards the gentle end. The darkness is soft against your skin, a cool and soothing touch that washes away the tension of the day. You are weightless, floating in the zero gravity of your own imagination, supported by the invisible web. There is no up or down here, no forward or backward, only the eternal and peaceful now of the void. The black hole is not a threat. It is a doorway to a place where time stops and sleep begins. You can feel the pull of the sleep horizon, drawing you gently in, closer and closer to the center. The great monsters are closing their eyes now, one by one, extinguishing the fires of their accretion disks. The universe is turning down the lights, dimming the galaxies until they are just faint smudges in the deep dark. It is a time for resting, for letting the heavy gravity of the day slide off your shoulders. The greedy hunger is gone, replaced by a profound satisfaction, a fullness that brings the deepest peace. Everything is quiet, everything is still. Everything is exactly where it needs to be in the night, drifting, floating, falling gently into the velvet softness of the ancient space that surrounds you. The stars are whispering, hush, to the void, a soundless vibration that calms the mind and slows the breath. You are safe here, protected by the vast distances, cradled in the arms of the silent cosmos. There is nothing left to learn tonight, nothing left to understand, nothing left to do but drift. The questions have all dissolved into the mist of the nebula, leaving only the quiet comfort of the dark. The cosmic race is finished, and the winners are sleeping on their thrones of gravity and dust. The greedy seeds have become the quiet guardians, watching over your rest with infinite patience. You are part of their galaxy, part of their story, safe within the spiral arms of the night. Let yourself go. Let yourself drift deeper into the feeling of heavy, warm relaxation. The space around you is a blanket of stars, wrapped tight and warm against the cold. Breathing in the starlight, breathing out the darkness, slow and steady, deep and calm. The rhythm of the universe is your rhythm now, a slow pulse that beats once every billion years. It is the heartbeat of the black hole, slow and heavy and deep, lulling you to sleep. You can feel it in your bones, a resonance that brings a heavy, sweet tiredness to your eyes. The eyelids are heavy, the mind is heavy, the body is heavy. Going deeper now, past the event horizon of sleep, past the point of no return, into the singularity of dreams. The light is fading. The sound is fading. The thoughts are fading. There is only the soft, warm darkness holding you. It waited for you. It waited for this moment of perfect stillness. And now it is here. The ancient peace, the cosmic silence, drifting down through the layers of time, down through the clouds of gas, down into the deep, deep rest. The monsters are sleeping. The stars are sleeping. The galaxies are sleeping. You are sleeping. Safe in the vastness, safe in the quiet, safe in the dark. Good night to the dawn. Good night to the monsters. Good night to the light. Good night to the stars. The universe is closing its eyes. The story is over. The silence is here. Drift, float, sleep, deep, silent, dark. Rest. Good night.